Hello students, welcome to this session. In this session, we will discuss about the limbic system and we will see how it influences motor control and learning. So if you see, limbic system is a complex network for interconnected brain structures that play a crucial role in wide range of functions that includes emotion, memory, motivation and learning. It is often referred to as a emotional brain because its key role in generating and regulating our emotional response and behaviors. And other important thing, the limbic system is not a single isolated structure. Instead, it's a group of interconnected brain regions like hippocampus, amygdala, hypothalamus, and part of the prefrontal cortex that works together to manage emotional and behavioral processes. So if we see through example, if we consider a situation where we are learning to ride a bicycle, so in the beginning, there might be fear of falling and fear of uh, maybe not learning the things very effectively, and that fear is actually processed by the amygdala. So at the same time, the hippocampus helps to form a memory of how a body is balanced during the activity. And with practice and motivation regulated by the limbic structure, we eventually develop the confidence and motor learning. Through this involvement in emotion regulation, motivation, implicit learning, reward processing, and the stress response, the limbic system significantly influence how we move and learn motor skills. It helps shape not just our motor behavior, but also how we acquire motor skills over time and the emotional context that becomes associated with those moments. For example, when a child is learning to play the piano, the feeling of joy or praise from the parents acts as a reward. And that emotional response processed in the limbic system not only motivates the child to continue practicing, but also the learning of the movement patterns involved in it got stronger. At the same time, on the other hand, if someone experiences repeated failure or stress while trying to perform a task, the negative emotional context can inhibit motor learning. It restricts the motor learning. And this is how the limbic system creates an emotional backdrop that either enhances or interferes with motor control and learning. Now, let's take a look at the key components of the limbic system. So, each of which contributes uniquely to motor control and learning by influencing our emotional and physiological stress or states. So, amygdala. So, this particular region is primarily involved in processing emotion, especially fear and anxiety. It helps us to evaluate potential threat and generate rapid emotional and behavioral responses, like a fight or flight reaction. So, for example, if suddenly we are encountered to a barking dog while walking, our immediate reaction is guided by the amygdala. The next one is hippocampus. So the structure hippocampus is very crucial for formation and consolidation of new memories, particularly declarative memories. And the declarative memories are the memories uh, we consciously recall, such as facts or the event. So for motor learning, the hippocampus helps encode the context in which the learning occurred, like remembering how you learned to drive or how to learn swimming, all these things. Then hypothalamus. The hypothalamus actually regulates fundamental physiological functions such as body temperature, hunger, and thirst. It also plays a significant role in emotional regulation and stress responses, which in turn affects motor performance. So, for example, anxiety can elevate your heart rate and muscle tension, thereby influencing how you move. Then the other part that is very much important is thalamus. So the thalamus actually acts as a brain's relay station, directing sensory information to the appropriate cortical areas, including the limbic structure. It is very essential for maintaining attention and awareness, both of which are critical for precise motor control, like focusing on the ball while playing tennis. or maybe learning any other skill activity, or maybe focusing on any physical activity also. Then cingulate cortex. So this area actually helps with decision making, emotional regulation, and even pain processing. So it integrates emotional input with motor planning, which is why emotional states like frustration can affect our motor execution or learning process. So if we see together, these components create a dynamic network that not only influences how we feel and respond to our environment, but also how effectively we learn and perform motor tasks. So now let's explore one of the most essential foundation of neurorehabilitation and movement science. That is how the central nervous system controls posture and voluntary movements. So what we are seeing in this particular diagram, it's a representation of the functional hierarchy of the CNS. So ranging from higher cortical centers to spinal cord outputs and finally to muscle activation. So we will go through each step uh, one by one. So the first thing is sensorimotor cortex. So it is responsible for planning and the initiation of the motor movement. So at the top of the hierarchy, there is a association cortex and motor cortex, which are responsible for planning and initiation voluntary movements. And the association cortex integrates sensory input with memory, goal, and intent to formulate a movement plan. And this plan is then passed to the primary motor cortex, which sends descending motor commands to the spinal cord and other brain regions. This is the part where conscious voluntary movements actually originates. Then the other part is basal ganglia. So this basal ganglia is responsible for movement selection and inhibition. So the basal ganglia actually acts like a control gate. So they facilitate desired movements and inhibit or restrict the unnecessary movements. And this is very essential for smooth, goal-directed actions, especially in complex or multitasking environment. Then the other part is thalamus. So thalamus is known as the relay to the cortex. So thalamus is a major relay that and integration hub. So it receives input from both the basal ganglia and the cerebellum. Then it relays process signal to the motor cortex for refined motor output. So this feedback loop helps to maintain the accuracy and the coordination in the movement. Then we have the cerebellum. So it is actually responsible for coordination and error correction. So the cerebellum acts as a coordinator and real-time character. It receives sensory feedback from the spinal cord and brainstem. It compares intended movement with actual performance. If there is any mismatch, it sends a correction signal. So the process is very crucial for maintaining precise balance and timing of any motor movement. Then we have the brainstem. So brainstem is actually for the postural and the reflex control. So the brainstem actually supports automatic postural adjustment and the reflexes. It maintains muscle tone, balance, and automatic movement patterns like walking or maybe standing. And also, it ensures your body is stable enough to perform that fine movement. And the other particular part that is very important is limbic system and hypothalamus. So as we know, the limbic system is actually responsible for emotion and the motivation. So the limbic system, along with the hypothalamus, it provides emotional and motivational input to the motor control. The motivation can be feeling of thirst, fear, or desire. It can be intensify or initiate the movement. So let's say, for example, fear can trigger a faster than usual sprint due to emotional drive. And this is why movement is not just mechanical, it's emotionally contextual. Then we have the spinal cord. So final, the output to the muscles um, use the pathway through the spinal cord. So all descending inputs from the motor cortex, brainstem, and cerebellum converge in this particular part. The motor neurons activate specific muscle groups in a coordinated sequence, and at the same time, the sensory feedback is sent back to the higher center to adjust and define the movements. So let's take an example. So let's say if we are sitting at a table and we decided to reach a glass of water that is placed in front of us. So first of all, sensorimotor cortex, um, your association cortex process the visual and spatial data, that let's say how far the glass is, how heavy the glass is, all these information will be processed. So the motor cortex plans the action, and that plan of action can be, let's say, shoulder flexion, elbow extension, wrist supination, hand open, or maybe finger extension. Then the basal ganglia selects your right arm for the movement and suppresses any other unnecessary motion or the movement that may be because of left hand or maybe because of the legs. Then the thalamus comes into the picture and it relays the updated movement plan between the basal ganglia, cerebellum, and the cortex to fine tune the action. Then the cerebellum, it monitors the movement in real time. If your hand shakes, it sends the correction to the brain and adjusts the arm path or the uh, movement. Then the brainstem, actually it ensures that our torso remains upright, stabilized, and your core as we, let's say, further lean forward. Then we have the limbic system. It actually adds the motivation. The motivation can be maybe you are thirsty or emotionally driven, so it will boost the focus and the urgency of the movement. Then we have the spinal cord. So to execute the command, motor neurons activates the muscle in your arm and hand, and you grasp the glass and bring it back smoothly and accurately. So all these systems work together in synchronization to perform a very, let's say, simple or to a complex task. So also we should observe that if any part of this system is damaged, then in the situations such as in Parkinson, stroke, or any type of abnormality, the result, that is the movement, it will be very slow. It may be uncorrelated, uncoordinated, or maybe it looks like impossible. So the coordination and synchronization between all these part of the brain is very important while we are performing any motor activity. Now, let's see how the limbic system plays a role in motor control, memory, and learning. So, first, emotion and emotional memory, that is one of the key components here in is the amygdala. So, it's heavily involved in processing emotions, especially fear and the anxiety. So, let's say if you were once chased by a dog, and then that experience, particularly the fear that you felt, gets encoded as an emotional memory in your amygdala. Now, even let's say after years, just seeing a dog might make you feel anxious or alert, even if the dog is not threatening. So, this emotional response can affect how we behave, how we move, and even how we learn from our environment. So now on to memory formation and consolidation, if you see. So this is where the hippocampus comes into the picture. Its main job is to take short-term memories and um, turn them into long-term memories. So this is a process that is called the consolidation. So the consolidation is a process where the short-term memory is processed and converted into the long-term memory. So let's say when we are preparing for an exam, or you are preparing for an exam and reviewing the material, your hippocampus is actually activated. but there is a especially active during sleeping time. So when it helps solidify what you have learned so that you can recall it later. So that's why getting a good night's sleep after studying is very important. So if we put all these things together, we will see that the amygdala and the hippocampus help shape how we learn and remember, especially when emotions are involved. And this is really important in motor learning too, because our emotions like stress, motivation, or even fear can influence how well we acquire new motor skills or retain what we have practiced or learned. Now, let's look at some more specific ways the limbic system influence our motor control and learning. So, starting with reward and motivation. So, instead, the limbic system we have structured like nucleus accumbens and the ventral tegmental areas, that is also known as the VTA. So, these parts of the brain is responsible, or we can say as a reward circuitry, and these are responsible for releasing the dopamine. So dopamine is a chemical that makes us feel pleasure and satisfied. So if you think about example, like for example, let's say last time when you achieved a goal or achieved something, maybe you have solved a difficult problem or got a compliment after performing well. So that satisfying feeling that you experience, that was actually the because of the dopamine released. So the limbic system uses this as a signal, kind of like saying appreciating you or providing you the appreciation. And this reinforcement helps in forming habits and sustaining motivation. Now, if we move on to the motor control, the limbic system does not act alone. It interacts closely with the basal ganglia and frontal cortex to help regulate motor control. So let's take the example of playing the piano. It's not just about hitting the right key. You are also experiencing emotion through the music. Your limbic system contributes to coordinating your movements with your feeling so that the music you play is expressive and it's not just the mechanical. And finally, if we see how the learning and memory retrieval is happening, so here the limbic system works in tandem with the neocortex. So the hippocampus actually helps to retrieve the memory, and the amygdala adds emotional weightage to it. So that when you recall a special memory, it will be retrieved very efficiently and seamlessly. So let's say the memory like uh, your first stage performance or maybe your graduation day. So it's not just the detail that come back to you, but also how you felt in that particular moments. And that's because the emotional and the memory centers are tightly linked or in sync. So these emotional connection make learning more effective. If a learning experience is enjoyable or meaningful, you are most likely to remember it again. So this all is done by the limbic system. So in a way, we should thanks to the limbic system that it provides the recalling facility of any kind of memory in a better way or maybe more efficient way by incorporating the emotional quotient with that particular memory. Now, let's understand how the limbic system integrates with other part of the brain to influence our action. So, as we already know that limbic system is not just the isolated system, it communicates with many other brain regions. It sends the neural signal upward to the frontal lobe, where high-level thinking and decision making happen, and also downward to the brainstem, which controls basic life function. So in this way, the limbic system can directly influence our motor output, how we move and respond physically. So to function a human being, we rely on the coordination of three major systems. The first one is sensory system, the second one is motor system, and the third one is motivation system. So the sense Sensory system actually help us to perceive the word information that is around us, like vision information, sounds, smell, and the touch. The motor system, it actually controls our movement. For example, how we walk, how we speak, how we write or play any instrument. And the motivational system, which is actually actually nothing but our limbic system. So this system actually provides the emotional and the motivational drive behind our actions. So uh, for any meaningful behavior, whether it's studying for an exam, playing a sport, or comforting a friend, in all these cases, these three systems need to work together. The limbic system actually gives us the emotional reason, or let's say why we are performing that activity. The sensory system gives us what is all around, and the motor system actually delivers how we are performing that particular activity. Now let's move further and see how the limbic system and its connections contribute to recovery and learning after the injury. So till now, whatever we have discussed is all about the normal human, or we can say the human without any brain injury or without any neural problem. But the injured brain will act in different way. So when the brain is injured, especially in areas involved in the motor control and memory, recovery of function is not just happen passively or about itself. So it involves complex mechanisms that allow the brain and spinal cord circuit to reorganize themselves. And this particular process is known as the neuroplasticity. So in children's or in infants, the brain is highly adaptable. So for example, if one side of the brain is damaged early in life, the opposite hemisphere might take over the lost function. But in older individuals, recovery relies more on reorganizing the existing system, using what's still intact to compensate for what we lost. So, for example, uh, for any complex behavior like coordinating a motor task that involves multiple steps, the brain does not work in isolation. The limbic system, cortex, hypothalamus, basal ganglia, and brainstem all work as one integrated unit. If even one part of this network is damaged, the entire system may initially fail to function properly. But here's the important thing or important part. If we don't encourage recovery through rehabilitation therapy or stimulation from the environment, this malfunction can become permanent. So, neuroplasticity is not automatic, it needs the right input, and scientists are still investigating the optimal time for encouraging this plasticity. See, we know that early intervention is helpful, but the exact window for the peak recovery potential are still not very uh, understood. So that the overall conclusion is we should start the rehabilitation process as soon as possible. So now let's see how the limbic system influence our motor control. So you might already know that the primary motor cortex in our brain is the reason responsible for executing voluntary movement like lifting your hand or walking. But what is interesting is that the limbic system, particularly the cingulate cortex and structures like basal ganglia, plays a supporting but very important role in modulating these movements. So, what does it mean? It means that the limbic system adds an emotional and motivational layer to our movements. It decides how much energy, focus, or drive we bring to the task. So, for example, imagine a student performing in competition. If they are emotionally charged or highly motivated, their movements and coordination may actually improve. And that's the limbic system at work. So, it enhancing motor control based on the emotional state. This is also why athletes often perform better under high stakes condition. So their limbic system kicks in, flowing the motivation and focus, helping them to reach peak performance. In survival scenarios, this effect is even more dramatic. If a person faces danger, their emotional arousal can lead to extraordinary physical responses like running faster or lifting very heavy objects that is far beyond their usual capacity. And again, this is the limbic system that influencing motor function based on emotional urgency. So now let's see how the limbic system is influencing our learning. So one of the most important part of the limbic system when it comes to learning is the hippocampus. So this structure is like the brain's memory librarian, we can say. Actually, it helps us to form and organize new memories, especially when we are learning something that requires conscious recall, like facts, concepts, or steps in new skills. So this part of the brain is very actively contributed in all these learnings. So let's say, for example, think about learning to play a musical instrument. So in the beginning, everything feels very unfamiliar, very weird. But as you repeat scales or practice the musical piece over and over again, your hippocampus helps um, store and also the new pathways those are there corresponding to those particular learning or activity got stronger. So with time this leads to improved recall and performance. But there is another layer to this, that is the emotion. So the limbic system including the amygdala processes emotion. So when an experience has a strong emotional content, either joy, fear, excitement, or maybe even stress, it tends to be remembered more vividly and for a longer time. And this is known as the emotional memory consolidation. That's why students often remember where they were or how they felt during important life events, even after many years. So emotion acts like a what we say acts like a highlighter for the brain, making memories more stronger, and so recalling of those memories. So in this particular session, we have seen about the limbic system and its contribution in motor learning and how it can be useful for neurorehabilitation. So thank you all for your kind attention and participation.